Chapter 6 of Pre-Calculus, Lesson 1, looking at vectors, and in this portion of the lesson we want to look at the unit vector. The unit vector is a vector that has a length of 1. And in order to calculate the unit vector, what all this means essentially is what you want to look at is this right here. That if you take 1 over the magnitude of the given vector and then you multiply that, that's a scalar, 1 over the magnitude, it's a fraction, that's a scalar number. If you multiply that then times the components of the vector, use it as a scalar, then the result will be the components of the unit vector. And the unit vectors provide a way to represent the direction of any non-zero vector, and then any vector in that direction or its opposite is simply then a scalar multiple of this unit vector. In other words, if I have an arrow pointing in a particular direction whose length is 1, if I know what the A component is and the B component is, so I have the components of the vector, any other vector going in that exact same direction or even in the opposite directions is simply a multiple of that unit vector. So I simply multiply however long an arrow I want, and I multiply each of the components by that number. So if I know what the unit vector is and I have its components and I want to multiply, I want to make that arrow, let's say that vector have a magnitude of 20, I simply multiply 20 times the component of my unit vector. So the unit vector becomes a very important tool that we can use moving forward. So if we ask to find the unit vector of this vector -3, 2, and then verify that it has a length of 1. That means once we find the component, we're going to find the magnitude to verify that we come up with 1. So remember, in order to do this, we simply find the magnitude, we put 1 over the magnitude and multiply it by this vector, and that will give me the components of the unit vector. And then we'll find the magnitude of that unit vector, a squared plus b squared, take the square root, and I should get a value of 1. So the magnitude of this vector is the square root of -3 squared, which is 9, plus 2 squared, which is 4. So the magnitude of this is 1 over the square root of 13. To determine the unit vector then, I take 1 over this square root of 13 and I multiply it as a scalar times the vector that I began with. So when I multiply this, I have this new vector of -3 over the square root of 13 and then 2 over the square root of 13. Now what I've done is I've taken the vector -3, 2, that would be this vector right here. Okay, sorry, I know that's not a straight line. Where this is -3 and this is 2. And what I've done is I've shrunk this down so that this length is now a 1, because the length of this is square root of 13. I want this to have a length of 1. So by multiplying by this, what I now have done is I have these components. This is my A component here, and this is my B component, and if I take this squared plus this squared and take the square root, the length or the magnitude I should have is a 1. And now any arrow going this way, going through this point, this vector pointing this direction, or even this direction, is simply then a multiple of this unit vector, meaning all I have to do is multiply this unit vector by however long I want my arrow to be. So let's confirm that this actually has a magnitude of 1. So I take -3 times the square root of 13 squared plus 2 times the square root of 13 squared, and I take the square root because that's the magnitude. Okay, so -3 squared is 9 and radical 13 squared is 13, so I have 9 over 13, and then 2 squared is 4 over 13, so I have this as then the square root of 13 over 13, which is 1. The square root of 1 is 1, so the magnitude of this is actually 1, so this is the unit vector, and it's the unit vector for any vector that goes through this point or in this direction, -3, 2. So any vector that goes through -3, 2 or is pointing in that direction is simply a multiple then of this unit vector. So all I have to do is multiply this unit vector by whatever size arrow or whatever magnitude arrow I desire. Okay, so that's why you want to be able to determine the unit vector. That's how you determine the unit vector, and then this is how you can confirm that this actually is the correct unit vector. So what would be the unit vector if I had 1, -1? So again, I want to find the magnitude of this. And so 1 squared plus 1 squared is the square root of 2, so the magnitude of this vector is the square root of 2. I take 1 over the square root of 2 and multiply it by my original vector, and so I have 1 over the square root of 2 and then negative 1 over the square root of 2. This would be the unit vector. So any vector that goes through this point 1, negative 1 is simply a multiple of this. Now all I want to do is confirm that this actually has a magnitude of 1. So I will take 1 over the square root of 2 and square it, add it to negative 1 over the square root of 2 squared, and then take the square root of that value. So this squared is 1/2 plus this squared is 1/2. 1/2 and 1/2 is 1. The square root of 1 is 1. So this indeed is my unit vector. We've been representing vectors using the component form. There is another way to represent vectors, and that is what we call standard vector notation. In standard vector notation, the horizontal axis is considered the I-axis. The vertical axis we would consider the J-axis. So to represent the vector, all we do is we put a value in front of I for the horizontal component and a value in front of J for the vertical component. So if I had the vector 3, 4, and I wanted to put it in standard vector notation, I would simply do 3i plus 4j. So that's a 3 to the right and then a up 4. So this would be standard vector notation.